Hello everyone. So, how you all are doing? I hope you all enjoyed your weekend, right? So, before we begin our chemistry lectures, I will first introduce myself. So, I am Dr. K. Shani Randima. I am a BAMS graduated doctor and also I have studied chemistry special degree at Institute of Chemistry and also I have done my masters in applied organic chemistry from University of Colombo, right. So, that is a brief introduction to myself and so we will go to our lecture today, right. So, as you can see from the screen, we are now today going to talk about a little bit of entropy and energetics, right. So, actually this is a topic which is coming in A2 syllabus. So, actually it is a continuation from AS. So, this is something deal with the thermodynamics, right. I hope you all are familiar with what is thermodynamics. So, if I simply explain to you, so in chemistry we are mainly talking about happening of chemical reactions, right. So, whether a chemical reaction is happening normally or naturally, or in other words I can say whether the chemical reaction is happening spontaneously, everything will be determined by the thermodynamics, right. So, if I take these two words, entropy and energetic, I am quite sure that you are familiar with the term energetics. But do you ever heard about the entropy? Yes? Anybody who knows? Yeah. So, this entropy term will be something new for you. So, today I will explain it in a nice way, right, so that you won't forget it for the entire lifetime. So, this entropy term, even though it is very big and very hard, it is very simple to understand if we know the concept, right. So, entropy means measuring the degree of disordered nature of a substance. So, when I say disordered nature, what do you understand by disordered nature, right? So, if I take the example as our house, right? So, if you just don't sweep the house, if you don't arrange the ornaments in the house, if you just don't arrange the chairs, you don't arrange the bed linen, what will it be? Your house will be just a mess, right. So, it will be just a disordered nature, right. So, naturally everything including our house, including ourselves, anything will like to get disordered. That is same in the chemistry as well, right. So, when we take a chemical substance or when we take a chemical reaction, everything like to be disordered, okay. We will learn about in more detail. So, chemistry is all about chemical reactions. As I told you, simply we can describe a chemical reaction as this, okay. So, I can just simply explain a chemical reaction like this: reactants going into products, right. So, this is what happens in any chemical reaction. So, when these reactants are going into products, there are bonds in these reactants and they will break, okay. And to form the products, there will be new bonds forming, right. So, in chemistry, when a reaction is happening, always what happens is the bonds will be broken and some bonds will be formed, okay. So, there are so many chemical reactions that are taking place. So, in our environment there are so many chemical reactions and also within our body there are so many chemical reactions happening. And also if we want to produce something, if we want to manufacture something, or if we do some experiment in the lab, so we will be conducting chemical reactions, right. So, what we need to know is whether a certain chemical reaction is happening naturally, that means without our interference, without ourselves providing anything. Okay. So, another term that we use there is a spontaneous occurring of a reaction. That means the reaction is happening by their own. Okay. So, to predict whether a reaction is happening by their own or spontaneously, we learned thermodynamics is one factor, right? So, revising your thermodynamics knowledge, right? So, when you studied the thermochemistry, we studied there are two types of chemical reactions, right? So, what is that? Exothermic reactions and endothermic reactions. Okay. So, what is exothermic? Exothermic means when this reaction is happening, that means when the reactants are going into products, the heat energy will be released to the environment. That is meant by the exothermic, right? So, when energy is released in a chemical reaction, the products will be at a low energy state than the reactants, right? So, the products will be more stable. Okay. So, I will give you this simple example. So, imagine there is a small child, right? So, when we feed that child, what happen? He get all sort of energy. He become more energetic. So, after that child eat and he get energetic, will he stay at a certain place? Are we able to keep him at a certain place? No. That child will be playing or else that child will be just running here and there. He will be very energetic. That means in simple words I can say that child will be so unstable. So, it is same with the chemical reactions also. So, if the products are having more energy, that means the stability of the products is less, right? And also, if the products are having less energy, then the stability of the products will be high. So, in exothermic reactions, the products will be having low energy. Therefore, the products will be more stable. So, in nature, usually when something is happening, we always tend to go towards stability. So, it is same like the chemical reactions, right? So, chemical reactions also, they proceed searching for stability. So, we say exothermic reactions are happening spontaneously because they go for the stability. But what about the endothermic reactions? Do you think whether the endothermic reactions are all non-spontaneous? No, it is not like that, right? So, endothermic reactions means for this reaction to happen, it absorbs energy from the environment, right? So, when these reactants absorb energy, what happens? The products will be having high energy. High energy means, as I told you, it is a less stable state, right? But endothermic reactions are also happening, right? So, sometimes endothermic reactions can happen at room temperature, right? So, from that fact actually you can understand this whether this thermodynamics, right? That means whether it is exothermic or endothermic is not only the factor which determine whether a reaction is happening spontaneously or not, right? So, there should be another factor. So, that is actually the entropy as we were discussing, okay. So, entropy means, what is entropy? So, I just explained to you. So, you can see from this picture, right. So, from this picture you can see it is a very good example for entropy. So, your headphones, always it tends to get disordered. So, every time when you want to use it, what you have to do? you have to just make it ordered. Okay. So, likewise, entropy means the degree of disordered nature. Okay. So, the entropy, as you can see from this slide, we are denoting it as delta S, right. So, that is a measure of disordered nature, right. So, there is a very important point that you have to remember when it is called, when we talk about the entropy, that is the temperature. Okay. So, when temperature is increasing, the entropy will be increased, right. So, why I say so? I will explain it to you, right. So, for that thing, we will go for the other slide and explain, right. So, as you can see from this picture, there are 3 different states of matter. Okay. So, what are the 3 different states? As we all know, it is the solid, liquid and the gas, right. So, when it comes to solid, you can see from the picture, solids have the particles which are very closely packed together, so that they can't move freely. So, they will be very close to each other and can't move. So, they will be in a very ordered manner, right. So, we say the solids are having very less entropy. So, what happens when the solid is heated? Solid is converted to the liquid. You can see it from the picture. So, as you can see from here, in the liquid there are more spaces in between the particles, right. So, these particles, they can move very freely, they can move here and there. So, when we can move something here and there, that means it will be more disordered. Okay. So, that means in liquids compared to the solids, the entropy is high. Therefore, you can see when we increase the temperature, what is happening? The entropy is increasing, right. And next we will go for the gases. So, you can see in between gases, the particles are very big space, right. They can move very freely, they are not having much as attractions. So, they can go wherever they want, right. So, that means the disordered nature of a gas will be more. So, when that disordered nature is high, we say the entropy or delta S is high, right. So, when it is a temperature, when temperature is increasing, you can see the disordered nature or the entropy will be increasing, right. So, going back to the previous slide, so this is a very good example where the entropy is increasing with temperature, right. And also when you consider the 3 states of matter, solids, liquids and gases, gases are having the highest entropy. Okay. So, is there a state without entropy or entropy is 0? Yes. So, if we take a very perfect crystal, if we take a perfect crystal at absolute 0 or we call as 0 Kelvin, if it is a perfect crystal, we say that the entropy is 0, right. So, I think you understood really well about the entropy. So, always when a chemical reaction is proceeding, the natural way is the chemical reaction is proceeding for the increase in entropy, that is the nature, right. So, I will recall back the previous example I told you. So, our house always it tend to get disordered, right, and also our body it tend to get disordered unless we comb our hair or we wear clean dresses, right. So, likewise it is same in the chemical reactions also. So, you have to remember it is not just the thermodynamics which will be determining whether a reaction is happening spontaneously or not, but we have to consider about the entropy also.